Hey everybody, this is Larry, this is me going with Q3 of the bi-weekly contest 147, longest subsequence with decreasing adjacent difference. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one was definitely very tricky, very hard. Only 400 people got it. And honestly for me, I have 3 wrong answers, but a lot of it was just because Python was a little bit silly with top down. Apparently, you can do this. A lot of people did do it with Python bottoms up, and especially with space optimization, it is okay. But yeah, I mean, I don't know. It's just Leetcode things, and I ultimately got it with Java. So I'm going to explain the way that I did it, and then we'll go over a solution together. With respect to optimizing it, right? To do the bottoms up in Python. So this code I will show you in Python, but full disclosure is that during the contest I converted it to Java to get it just barely fast enough. So I don't know. Yeah. Okay. So the idea here is that if you write a so sometimes or very often the way that I think about these things is just writing and I'm going to start this video, this explanation with the caveat that you need to be good at dynamic programming for now. I don't want to go over all the new, the beginning parts of it. So let's just say you know how to write dynamic program, you know how to analyze the complexity, you know how to do all these things. And we'll go over it slightly, but I might be going a little bit fast on the basics, right? This is a hard Q3, only 400 people got in it, so you haven't at least got the fundamentals right. Understanding is not the same as doing, and you have to be able to do easier problems and not just understand them, and to be able to even do this one, right? Anyway, the first thing that I thought about is just having this idea of, okay, well, let's just call it a function, right? We have this is probably going to be dynamic program, but I knew it was going to be too slow because I have an index, I have the last number we care about, and the difference, right? So we're going to look at it this way. Then index obviously is going to be 0 to n. Last is going to be 0 to 300 is just the last number, and then difference, or the max difference, is 0 to 300, right? And the way that I originally thought about this, and of course this is memorized, say, is that you have something like this, right? 0 maybe, I forget, but and then you have the last number. I forget why I used last, but it's just like the last number. So then now you get the difference. But keeping in mind that, well, we have the last number, then the difference. You don't really need the last number. So then I was like, okay, that's fine, right? Because the last number doesn't, it's embedded in difference. Because initially the way that I thought about it is that, okay, well, it's part of the difference, so then we can, like you could kind of, it's just a dimension, but you can remove last because difference would give you, give an index obviously gives you the current number, the difference should be good enough to kind of think about it, right? And then if I did something like this, then in a brute force kind of way, then there are 2 ways to write it, right? One is that the more naive way to write it may be that for like you have another j in range from index to n, or index plus 1 maybe, right? And then maybe like if num sub index minus num sub j, the absolute value of is less than or you go to difference, then you go index, or you go j, and then the new difference, right? Whatever this is. So this would be, and then you take a best over all that, right? So best is equal to max, best, right? So something like that, right? So this would be the first way that I thought about it. And of course this is n squared, and being 10 to the 4th is going to be too slow, right? Again, I'm skipping a bit on the dynamic programming things. I would say even n squared is too slow, but this is actually worse than that, right? Because there's also a difference. So it's going to be n squared times d, where d is the delta, right? The maximum delta. And And yeah, the delta being maximum of 300 is because each number can be only up to from 1 to 300. So actually, technically, delta could be only up to 299, but you get the idea. I'm going to say 300 because it's easier. But yeah, so this is going to be n squared times 300, or n squared times delta, or d for max delta, say. And either way, it's going to be too slow. And then the next thing to notice is that, well, we only have to go up to 300, right? So then the other way to think about it is that, okay, well, and maybe you can write it out, but you can reduce this to only 600 numbers, right? Or 601 numbers, say, or 599, whatever, right? Is that you can, because you can go up to difference, right? So then now maybe you have delta is in range from 0 to difference plus 1 to get it inclusive, right? And then now maybe yeah, the idea is that, okay, well, now the new difference is going to be some new index or next index where it's delta, right? So then you want to write something like this, and then what happens, right? Well, this is better, of course, but we have to think about it, right? Because how do we get the next index? Well, and what does next index mean, right? So delta can mean a couple of things, and delta could be positive delta or a negative delta. Though we want to do the absolute value. So then, well, with delta, and we could play around with real numbers. If delta is say 100, then and the next number we care about is just index plus delta or plus 100, right? So if delta, or if num sub index is say, I don't know, 20 and delta is 100, then we want to look up for 120. And in this way, there is a greedy idea of it, right? Because if you have multiple numbers that are 120, in this case, you obviously want to get the next one because you're trying to maximize the longest length, or maximize the length. So the next, the shortest distance is going to give you the longest length in a greedy kind of way. So this next index, how do we get it, right? Well, we can pre-process next index just by going backwards, which is that for each index, we can look at for each index, we can just pre-calculate all this, right? And there are ways to do it, and we'll go over my code of actually doing this. I mean, because this is the way that I did it. But you know, yeah, that's basically the idea. So let's just say, pretend for now that we have a magical way of getting next index in O of 1. But of course, you have to, just to be more precise, you have to get next positive index and a little bit more precise, but not precise enough to give you the answer, right? Okay, so let's just say we have this structure, right? Okay, let's say we're able to do this in O of 1. O of 1, we're happy with this part. What's the complexity? Well, there's a D here for delta for maximum difference and index. So this is going to be n times D, but there's still an O of D loop. So because of this O of D loop, this is going to be O of n times D squared, which is 300 squared, which is 90,000, times 10,000, which is way too big, right? What is that, like 9 billion or something, maybe? Whatever it is too big. So then now, can we reduce it more? So the one thing that I noticed is that, well, we actually reuse this a lot, right? Like next index, we get to delta, but because basically, okay, so the way that I think about it, after, and if you watch the live portion, I did write this out, and then before I noticed and then see it, is that, okay, well, what does go index diff do, right? Whatever, let's just do it. Well, go index is just you go to, you know, if you look at this, it just does a loop for delta in range from diff plus 1, right? Say, and then the idea here is that, okay, well, what happens if you have diff minus 1, right? And maybe I'll for whatever. Then now this is for delta in range of diff, right? And then, you know, minus 2. So this is kind of like the ... that I saw, right? And then as soon as I saw this, I was like, Well, that means that we're redoing some work with this delta, right? Because we can save these. So there are a couple of ways you can think about doing it, but the way that I end up going, and we'll go over the code, is just that in this case, it's going to be go of index diff -1, because that's what this is, right? So this delta is just equal to this for loop plus process for diff exactly, right? Okay, something like that. So that's the way to think about it. As a result, that means that this reduces to this, and this is the recurrence that we have. So right, so is equal to this plus just this thing now, right? Now it's exactly delta, and yeah, something like this. I mean, of course, there's some if statements of, you have to make sure that this is positive and so forth. But now you have n times d as the number of states and 3 things to do. So that will be fast enough. Or at least it should be, because Leetcode is silly and it times out on some constant optimization, so I had to convert it to Java. But we'll talk about that in a second, but that's basically the idea behind the structure of how to solve this problem. Yeah, and this is basically, honestly, that's pretty much it. This is my code. So here we pre-process the positive next index and the negative next index. As you can see, we go backwards the way that I did it, right? And then we do a for loop for each m. We go to plus d, and remember that if it's not found, then it just goes to n, which is the last element, which is fine. And then the next index also as well. And yeah, that's the idea. And then we see it, right? This is n times, I call it m, but let's just say d, because to be consistent with where d is the maximum number, maximum delta, right? And in the same way, yeah. Oh yeah, we have to also try to do every index with the maximum, just to kind of start it off, because every number can be the first number in the subsequence, right? And then here we just go, okay, well, we have at least one element. That's why you have the 1. And then here, if it doesn't go to the end, we just go to the next index. And that's pretty much it. So yeah, so this is, like I said, pretty tight, n times d. But unfortunately, Leetcode is silly and just barely times out in Python, and we have to convert it to Java. So what's the other way of doing it? So the other way of thinking about it is just doing it, well, bottoms up, right? The way that you can think about it is that you don't have to look at all the, I mean, it's the same idea, right? Is that you don't have to look at all the previous, you don't have to look at all the previous indexes. It's just the number that looks it up, right? Yeah, and you could do this in a very clean way, by some implicits, right? And I'm trying to do this like live, so if I'm a little bit slow, please forgive me. Oh, I also had this thing here because I wanted to test the max case. Obviously, yeah, obviously no Gucci, but like you should take that out. I actually forgot. I left it in because I was testing max case, and that would be the max case because you go through all of them for everyone. So I was just checking the timing. But yeah, but here then now for yeah. So then now for x in nums, right? So for each number we want to say, yeah, get the previous of within some delta, right? So then that means that the recurrence, as we said, it's going to be some dp of the previous x also, well, okay, so yeah, so this is x and then the previous number, right? So maybe and this could be, yeah, from 0 to 300, or well, yeah, and then this is some delta, right? And then now for delta in range from from yeah, up to 300, I suppose, or plus 1, just to be sure. right? Then dp of this is equal to the max of dp x delta, which is itself, plus the previous, right? And then also the plus version of this, of course. And of course, this has to be, yeah, just to, right? Something like this. Yeah, maybe that's why I didn't get it. But okay, is this the recurrence? Sorry, I'm doing this live, so feel free to fast forward. I feel like structurally this is similar to what I want, but oh yeah, I mean, of course it's a +1, but well, actually, yeah, I guess this is a little bit awkward. Actually, you don't even need to do it this way. This is just for previous, right? So yeah, we don't even need to actually. Yeah, we want the last number, and then here, then delta is equal to absolute value of x minus last, right? So then now we have delta x of delta, and then last. I guess this is about the same actually. So I guess I was mostly right, but we don't have to deal with other things. We just can't brute force on the. Yeah, I think this is a little bit cleaner because we don't have to go the delta route. But yeah, or like going delta up and down and checking the bounds, because this will always be in bound. And that's pretty much it, really, right? Yeah, and then we just have to set yeah, and then now so okay, so this gets the previous within some delta, but then now this delta we want to also propagate down, right? So that means that because we call it that, we also want something like delta is equal to, well, not as, but is equal to dp of x delta minus 1 plus, oh no, I guess not plus 1, it's just this, right? You want to minimize this over it. Yeah, except when you want to go yeah, I mean, I think something like that, right? So we have to do some thing where, yeah, so we want to propagate up. So then now for delta in range of up to m plus 1, I think, maybe, right? And then now we have f max of dpx delta. But we also need to do a thing where, yeah, we have to set dp of x of delta is equal to at least one, right? Yeah, now that it exists, right? I may even have to do 2 loops. And I think maybe that's basically it. But yeah, and then dp can now just be, I don't know, negative infinity times m for maybe m plus 1 actually. And then now we can just return max. Yeah. Okay, yeah. And that's pretty much the idea. Infinity, okay. Let's forget. Type error. Oh, whoops. Okay, so we're wrong on this one. But that's generally the structure. I have to figure out why this is wrong. So we have 2. Why is it 2? 16, right? So okay. Okay, so it goes all ones, which is fine, and then 6 is delta 10, so delta all, okay, that's good. And then now 3. Right. Why is this not 3? Did I do the loops in the wrong order? Maybe I did. Well, this should also just start with 1, so maybe there's something funky over there. Well, there's definitely something funky over there, but hopefully that's not so. But yeah. I mean, these are being 2s are fine. So this is. Okay, so then 6, 3. So then 3. It tries to do 16. 16 is fine, I guess. At 10, it will try to do. It's the delta, right? It tries to do, okay, this. This delta isn't right, is it? Something's wrong about this, obviously, but yeah. How am I tracing it? Okay, so 3, 6. So that means the delta is 3. So 3 plus 1, that makes sense. Did I do the loop wrong? So the maximum, the delta being higher, giving more things makes sense. But, okay, so it looks up here on the 3. Three. What am I doing wrong? Am I understanding it wrong, or am I doing it wrong? Okay, dp sub x, so 6. So yeah, 11 delta. Am I doing the direction wrong? No, it should be right. Is it this part? What is this part saying? Right? Does this part do anything? Am I doing it wrong? So you start at 1 delta and it's equal to the smaller number. Am I doing it wrong? think I'm doing it wrong. Okay, so this should be the other way. Okay, yeah. Because basically you want to set it up so that future delta is not... Oh yeah, yeah. Why would I think that? Because 11 delta... I think I'm just getting confused a little bit. Okay. But as a result, this should be fast enough. Apparently I still suck at it, you know, some stuff, but... maybe it isn't fast enough. Maybe I'm lying. But at least it's not wrong. Okay, actually fast enough. But how long did that take? But that's what I mean, right? With Python, it took 11 seconds. Come on. Like, how can anyone expect this to work, right? Like, or like reasonably be submitted, right? Like, if you just do what is it, $10? Like, if we run 3 times, this takes 2 seconds. It's scary, you know. And top down actually took 3 times as slow. So, but even then, you know, it's tough to say. But yeah, so that's basically the idea. I kind of messed this up at the very end. My apologies on the explanation part. But basically the idea is that, yeah, for all the deltas that are smaller, you get the better result. I don't know why I went the other direction. But yeah, that's pretty much it. And the reason why this is faster is honestly just a lot of overhead, right? With the memory storage, because 300 times this is not too big, but 3 million. So you think about all the memory that you have to allocate, and it just adds up over time. Like I said, it's a constant amount, but in terms of work, because it's still the same complexity with respect to m times d or n times d, but the space, this is just much tighter with m squared or d squared. So you know, but yeah, Leetcode things. Anyway, yeah, I hope this was kind of okay. Yeah, I mean, I think that's why bottoms up is tough, right? Given when I knew how to do, knew what I was going for, then that's because it's just easy to mix up the signs. But yeah, I don't know, it's hard. That's all I have with this one. Let me know what you think. Thanks for watching, and you can watch me solve it live during the contest next. So this at least does something. All right, let's go. Okay. Silly mistakes today. But my stomach is killing me. I just need to get enough. I want to. My goal is to get to. Okay, let's go. Finish this first. Introduce nums, longest subsequence, such that absolute difference between consecutive. How far behind am I? Oh, the leaderboard doesn't work. Oh no, there it is. That's not great, but oh, okay, maybe we can catch up. Absolute difference. Longest subsequence. Okay, n is 10 to the 4th. What's that? 10,000. Numbers is 300 though. 10. Alright, I'm gonna use the rest from now that I did in my head. Okay, I think I feel a little bit better. What a weird day. Okay. So 300 times that should be okay, right? So that means we have to, so it's tick, no tick. But then you have 300 square, right? Index, tick, no tick. So if we write something just naive, let's just write something naive for now. Okay. So you have index, last number, and then the absolute difference. The difference. But then that's going to be 90,000 times 10 to the 4th, which is not too big. Right. Okay. Oh, it's the longest, right? Longest is the greedy component. The greedy component would be that for each cell, we go as close as possible for the delta that is. That's not an easy one. Anyone got Q4 yet? One person, so maybe not. So okay, so this is tick no tick, so I don't know how I can just optimize that. I didn't get so many wrong answers on Q2. This would have been better. Okay, so then here, so it's greedy, right? So we just want this index and then the difference, and then it is just about oh, there's still a for loop there though. You definitely need n. This is longest. And you don't always first start with the first number. Okay. This was a good poem to go to the bathroom on, because I still have no idea. I thought I had some ideas to play around, but what about increasing subsequence? Does that change anything? I don't know how you don't test every number. Well, okay, so there's only 600. Okay, I see. Okay. I think I see it now. Only 600 numbers, because you only go up or down. But that's still entering. Okay, that's not good enough. Wait. Yeah, going up doesn't seem to help either, does it? Oh, I see. That's a hard one. That's a hard one, actually. Okay. Then now, I should have written it out though. I guess that's the thing, right? Just one for the current index. That's plus one. That's the now go of that's a hard one. I see. Okay. Write it out first and then we'll optimize later. Actually, we could just do that, right? So then here. Yeah, okay. You could just write it out. I just have to process all this. Yeah, okay. Yeah, got this. Okay, okay. Okay, that's not bad. We just have to be a little bit smaller. Okay, I think that's it. Okay. And then no. Okay, so then now pre-process. This is kind of wrong, but that's fine. No, you want an array. Technically 390, I guess, or 299. Right. D. Okay. I know it can be something about an index. Okay. Just wanted to run it, but okay, fine. Okay. I mean, that's a big number, but why is that? Oh, because it goes to diff. Oh, yeah, I'm dumb. It should be this plus 1, but then not this. Okay. 3, 4, 5. Okay. Let's try a really big number. Or I guess I could just do it here. I just want it anyway. That's a little bit too slow, isn't it? Why is that too slow? I mean, it's right. Why is it too slow? Why does it take 3 seconds a case? Should I YOLO? That doesn't make sense. And I do want everything, so I guess so. Huh? I mean, maybe we can have to optimize it, but let's YOLO submit it. Maybe I should have done the clear cache thing there. I should have done it, I forgot. Maybe it's gonna time out. Let's see. Is that much faster? I didn't submit it yet. I just want to see the timing. It was like 9.5 seconds or something, right? So not that much faster. Oops. I guess you can write this in Java, so I'm going to see here. Convert this to Java, please. Let's see what happens. Why is ChatGPT so slow on this one? I just want to see this timing. Java, it doesn't know how to do anonymous functions. Yeah. Let's try C++. I guess I could do it with bottoms up, but I don't know. I mean, 9 seconds is so tight, but it's in theory possible. I was just a little bit YOLOing, but I guess I can actually have written something like this where I guess this is actually doesn't have to be a thing, but is that really it? I guess so. How long does this take? It still takes a while, and also maybe the wrong answer. Do I forget a -1 somewhere? Oh, I guess this is equal to n. Because you want to add the current number. But it's not any faster, so it kind of moot. I don't know if it's a C++ thing or whatever, but it is what it is. Yeah, I mean, it is much faster actually. But is it enough for me to submit? Let's try fixing this here. We want it to be just n. Is that right? It is faster. I don't know. Is it fast enough though? Actually. How does that chat? Leetcode is silly. I mean, we do make optimizations. It's just I don't know. I might as well at this point. I might as well just do C++. Okay. Why is that string? No, we don't want memo to be this. We want memo to be just an index. Memo table using array, please. That's just lazy. What is going on? Let's run it real quick. Memo key. Oh yeah, I forgot to change that. It's actually easy to translate, but yeah, now is it fast enough? Yeah, unordered map, not even correct anymore. But okay, so then we want maybe how long does this take? Okay, so that takes fast enough. So let's YOLO submit this. Yeah. If it still times out, then it's so hard to guess whether it will time out, honestly. Because complexity-wise, it should be okay, right? 6 million. But I don't know. I mean, other than doing it bottoms up, how many people has gotten it? It is kind of bull. Leetcode is kind of silly. Like this is so fast. But oh, this should always exist, so like maybe I could do that a little bit better. I don't know. I don't think that's that much fast. Maybe I'm wrong on that one. This isn't right. That's why, but maybe that's fine. I don't know. This isn't even right there. This is also just not necessary. Do I, that's my thing, is that do I figure out how to optimize or not, right? But like 10,000 times 300 or it's not even 600 should be okay. So this is just kind of, I don't know, really upsetting that, like, I don't know if I'm optimizing something, and this is so fast actually. Yeah, is there a smarter way, maybe with greedy? I don't know, right? Like when it times out, it's just impossible to debug timeout on someone like this, you know? Probably could use an erase. Maybe that's fine. I don't know. Is that faster? Oh. Wait, what? No, just use N. Does that not work? Is that faster? It is a little bit faster, but is that fast enough? That's the part that is just like silly. Right. Something like that, right? Yeah, that actually end up taking longer. Is that consistent? No. So it could be anything, I don't know. I'm gonna submit it just because I don't know how. Maybe I have to solve the problem another way. I don't know. Like the complexity is right-ish, but I don't know. Probably. It is kind of okay. Let's look. We have 40 minutes left. Let's at least look at Q4 immediately. I think this one's a little bit tractable, but don't know. I mean, it shouldn't. What? That's the thing with hidden test cases, right? I mean, not the hidden test cases, but you don't know how many test cases there are. So it's I mean, because this should be it. I don't know. It makes me sad because I feel like this is a good problem otherwise. Yeah, I don't know that I know how to optimize this even more, you know? Is it on this part? I don't know. Like if we just remove this, how is it much faster? I mean, it's gonna be wrong, obviously, but what's it on the initialization? It's a little bit faster, but 5.7. I mean, it's slow, but it's, I don't know. Like, I feel like they just want us to make some, like, very constant optimization. And, you know, it's just not, because this should be good enough, right? That's just like 3 million. Or 6 million, because 3 times it by 2, I suppose. This doesn't matter. This should be okay. And even C++ wasn't fast enough. I wonder if Java is. That'd be funny if Java was fast enough, but not C++ or Python. And kind of have ideas, honestly, other than very minor stuff. So I might as well just copy the Java code and see if that works. How fast is this? I mean, this is gonna be fast, right? How do I even write it? I think that's really it. Was it just all zeros are fine? Alright, this is much faster than the C++ version, but is it right? Well, actually, if this is the case, oh no, that's right. It is faster. Alright, well, YOLO, what else am I doing? I hate Leetcode. I mean, we spent about, like, I don't know. We'll talk about it later, but at least 15 minutes on just like Leetcode things, right? Java. I should have done Java. I don't know why I did C++. I wanted to change it up a little bit today, but that's just dumb. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, these problems, this description, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.